हेलो सर, आवाज आ रही है?
यस यस आ रही है, आ रही है, आ रही है,
ठीक है
बिल्कुल आ
सर।
रही है। हो गया अब सारा सॉर्ट आउट।
हेलो सर।
यस।
आ रही है।
हाँ सर,
मतलब
आ
ठीक
रही
है।
है,
अच्छा,
बिल्कुल।
तो लेट अस स्टार्ट के जब तक ये हम स्टार्ट कर पाए, सर ज्वाइन करें तो उसके बाद ही स्टार्ट कर पाएंगे। ये सर की इंस्ट्रक्शंस है। तो इन द मीन टाइम वी में डिस्कस के कौन से टॉपिक पे अगली बार हम ये पीपीटी प्रेजेंट करें। कोई जो वॉलंटियर जितने भी हमारे एक्शन जुड़े हुए हैं, तो आई रिक्वेस्ट एनी ऑफ देम जो विलिंगली देना चाहते हैं। क्योंकि सर की इंस्ट्रक्शंस हैं कि एवरी एक्शन हैज टू प्रेजेंट वन पीपीटी मिनिमम। तो
सर देखो, हमारी आवाज आ रही है? यार ये ब्लॉक हो रहा है ना बार बार, वो देखो ऊपर ब्लॉक इनकी तरफ से हो रही है।
राहिल अच्छे से चल रहा है, कोई इशू नहीं है। आपको क्या इशू आ रहा है?
हेलो सर, आ रही है आवाज?
आ रही है, आवाज आ रही है, बिल्कुल ठीक से
ठीक है
चल
सर,
रहा है।
ठीक। ओके ओके।
हाँ हाँ।
तो रियाज कोई रिस्पॉन्ड नहीं कर रहा। मैंने जो प्रपोजल दिया है कि जब तक
नहीं
हम
नहीं सर, बेसिकली ये 2-3 सेकंड्स के लिए सारा म्यूट हो गया था, दैट्स वाई। सर आप रिपीट कर लीजिए प्लीज अब।
मैं ये कह रहा था कि सर की इंस्ट्रक्शंस हैं कि जब तक वो आएंगी तो हम ये थोड़ा होल्ड पे रखेंगे। जब वो ज्वाइन करेंगे तभी ये हम आज की पीपीटी जो है ये वर्कशॉप सीरीज स्टार्ट करेंगे। इन द मीन टाइम हम ये डिस्कस कर लें कि नेक्स्ट जो पीपीटी है वो कौन दे पाएंगे, क्या टॉपिक हैं। तो वो विलिंगली हमें बता दें ताकि हम नोट डाउन कर लें और उसके अकॉर्डिंगली हम उसको ऑर्गेनाइज कर लें और शेड्यूल कर लें। तो ये इतना तो डिस्कस कर ही सकते हैं। तो
यस
हमारे
सर,
जो
वो तो
एक्सेस
सर।
जुड़े हुए हैं दे विल प्रपोज एनी ऑफ देम विलिंगली, बिकॉज नाउ उनकी इंस्ट्रक्शंस हैं कि मैंडेटरी है हर एक्शंस के लिए एटलीस्ट वन पीपीटी हैज टू बी प्रेजेंटेड बेस्ड ऑन देयर एक्सपीरियंसेस, बेस्ट प्रैक्टिसेस और एनी अदर इशू। ठीक है ना? तो
यस सर।
हाँ, तो इस पर देखें तो अगर कोई प्रपोज कर रहे हैं कोई एक्शंस।
सर लास्ट वाले वर्कशॉप में भी वी हैव ऑलरेडी रिक्वेस्टेड देम ऑल कि अगर कोई भी इंटरेस्टेड है, जो कोई भी टॉपिक ऑफ इंटरेस्ट प्रेजेंट करना चाहेगा बेस्ड अपॉन हिज एक्सपीरियंस या नॉलेज एक्वायर की होगी ड्यूरिंग हिज स्टडीज और व्हाइल वर्किंग इन द डिपार्टमेंट और अदर डिपार्टमेंट्स, या मोस्ट ऑफ अस हैव गॉन सर टू अदर स्टेट्स टू अटेंड सम वर्कशॉप्स, कोई स्पेशल वर्कशॉप्स ट्रेनिंग प्रोग्राम्स अटेंड किए हैं हमने सर। तो वहां से अगर कुछ लर्निंग्स है, इफ एनीबडी वांट्स टू शेयर दैट विद देयर फेलो इंजीनियर्स, फेलो ऑफिसर्स, उसके लिए हमने ईमेल आईडी भी इनके साथ शेयर भी किया था कि वो अपने रिक्वेस्ट्स डाल देंगे अलॉन्ग। हालांकि उस टाइम पे वो पीपीटी शेयर करने की जरूरत नहीं है, जस्ट एक टॉपिक का थोड़ा सा ब्रीफ बता देंगे कि क्या करना चाहेंगे, तो अकॉर्डिंगली सर टर्न बाय टर्न, वन बाय वन हम टेकअप कर लेंगे। एज पर अगर हम थ्री प्रेजेंटेशन एक दिन में करते हैं सर, अकॉर्डिंग टू डैट वो जो टीम कर रही है काम इस पे सर, वो शॉर्ट लिस्ट करके तो उस पर कर सकते हैं, क्यू अप करके वन बाय वन उठा सकते हैं सर। बट लास्ट टाइम सर शायद ये दो रिक्वेस्ट भी शायद हमें ईमेल के थ्रू ही आई हैं। तो सिमिलरली सर और एक एडबल ही है फ्रॉम द जल शक्ति हाइड्रोलिक डिवीजन किश्तवाड़, ये तो वो भी अगर हम शेड्यूल कर सकते हैं उस वाले को भी, प्लस अगर और भी आ सकती है वो ईमेल आईडी पे ये शेयर कर देंगे सर।
पर एक तो ये है ना कि जो देना चाहें वो तो पहले हो गया। रियाज आवाज आ रही है?
उसमें सर हाँ, अगर इस टाइम भी कोई अपना इंटरेस्ट
एक है
एक्सप्रेस करना चाह रहा है
एक तो हो गया
बिकॉज
ना कि बाई
जब तक हमारा
चॉइस, बाई चॉइस वाला तो फर्स्ट हो जाएगा ना। तो बाई फोर्स तो सभी को देना है, तो ये माइंड में रख लीजिए। तो यू प्रिपेयर अकॉर्डिंगली, है ना? तो आज आज जो
यस सर
चॉइस
सर।
वाले हैं वो हमें दे दें शेड्यूल। नेक्स्ट तीन तो हमें नेक्स्ट सैटरडे के लिए चाहिए। तो बाकी
सर
भी
वी शैल
अपने अपनी
स्टार्ट।
तैयारी करें।
सर हम फिलहाल चॉइस से ही चलेंगे, जो जो रह जाएंगे फिर सर वो
वही कह
फिर
रहा हूँ ना,
बाई
पहले
फोर्स
चॉइस वाले
देंगे।
आ जाएं, बट वन शुड बी क्लियर इन हिज माइंड कि ही हैज टू गिव वंस ही इज एन एक्शन। उसको देना ही देना है। उसकी टर्न चाहे
सर
बाद
इस
में आए
टाइम भी,
पर आए।
अगर इस टाइम भी कोई अपना इंटरेस्ट एक्सप्रेस करना चाह रहा है सर, जब तक सर आ जाएंगे तो
वही
हम वो
इसीलिए ये
नोट कर
मैंने
लेंगे।
टॉपिक छेड़ा कि थोड़ा टाइम भी निकल जाएगा और डिस्कशन हो जाएगी इस पे जब तक सर ज्वाइन करते हैं। तो अभी तक मुझे कोई रिस्पांस आ नहीं रहा, मैं तो किसी की आवाज सुन नहीं पा रहा हूँ, एज इफ नोबडी इज कनेक्टेड।
Sir, 173 participants.
173 participants है, must be 50 actions must be connected and not even a single is speaking up by choice, then it has to be by force.
इट इज नाउ 184।
184।
अब हो गए 184।
तो रियाज आप जरा बोले, मेरी शायद इनका आवाज नहीं आ रही।
सर
आप जरा मेरी बात को रिपीट कर दें, मुझे लग रहा है कि शायद मेरी आवाज सुन नहीं पा रहे, तो मैं इंस्ट्रक्शंस
नहीं
सर
सर,
की
सब सुन पा रहे हैं सर, सर सब सुन पा रहे हैं सर।
अल्फाबेटिकली शुरू कर दो। ये ठीक है, then we'll select of our own and we'll nominate कि these actions will present for the any PPT for the next workshop। अगर कोई अपनी चॉइस से नहीं दे रहा, we have to organize it, तो फिर उस तरह से चलेंगे।
Sir, we have two officers, sir. We have two officers.
Okay.
From east side, Mr. Umar is in Waterworks Division, Srinagar, and one is Mr. Fayaz, who is Technical Officer in Mission Directorate, sir. They recently attended a workshop in Kolkata, sir, on the topic Operation and Maintenance Strategies of Rural Water Supply Scheme, sir. Sir, I request both of them, अगर वो next Saturday के लिए वो plan कर लेंगे, उस पे एक presentation, sir.
एक
उमर आप
प्रेजेंटेशन आपकी नेक्स्ट सैटरडे हो गई, तो आई विल
हाँ,
रिक्वेस्ट संजय, माय टेक्निकल ऑफिसर, इफ ही इज लिसनिंग, प्लीज नोट इट डाउन कि ये नेक्स्ट सैटरडे के लिए ये एक हो जाएगी पीपीटी। नेक्स्ट, एनीवन एल्स?
नहीं रियाजी, हाँ जी रियाजी।
जी संजय जी, जी
रियाजी, जो हमारी इसकी मेल हमने नई क्रिएट की ना इसके लिए,
जी
वो आप शेयर कर दीजिएगा सबसे, ताकि जिससे टर्म बाय करनी है वो विलिंगनेस और टॉपिक और प्रेजेंट किसने करनी है।
नहीं, प्रेजेंटेशन इनिशियली मैं कह रहा हूँ कि अगर पहले वो सिर्फ अपना टॉपिक और उसका थोड़ा सा ब्रीफ आप पेज
मैं
ऑफ,
वही कह रहा
इसके
हूँ,
बाद प्रेजेंटेशन सब्सिक्वेंटली, क्योंकि उसमें टाइम लग ही जाता है प्रेजेंटेशन प्रिपेयर करने में।
मैं वही कह रहा हूँ, अपना टॉपिक किसने करनी है वो अपना दे दे, कौन है वो, तो
यस यस
उसमें
यस,
वो मेल शेयर कर दीजिए आप सबसे ना, ठीक है।
ठीक
यार ऐसा
है,
तो
वो
नहीं
मैं
है
कर
कि
देता
बाकी
हूँ।
सब म्यूटेड है तो वो रिस्पॉन्ड नहीं कर पा रहे?
नहीं सर,
हाँ? ऑल आर
यस सर,
अनम्यूटेड।
यस सर, यस यस, दैट्स द पॉसिबिलिटी, यस सर। आई हैव अनम्यूटेड ऑल द पार्टिसिपेंट्स,
ओके,
अदरवाइज भी वो हैंड
they
रेज
can
कर
raise their
सकते थे
hands,
सर।
they can raise their hands, है ना, if they want to
बिल्कुल
say
सर।
anything।
भूपिंदर सिंह जी, आप एग्जिट हो जाइए,
तो आप नहीं,
या तो अपनी माइक म्यूट करिए या तो आप एग्जिट हो जाइए प्लीज। आप डिवीजन से क्यों नहीं अटेंड कर रहे हैं?
आप ठीक है, आ जाओ हम नीचे ही हैं। तो आपको आपको थोड़ा देखना होगा, आप अपने ड्यूटी से लगाएं तो
I have muted all the participants. अगर किसी को, if anybody wants to speak at some point of time, he may please raise his hand. अंजय जी, आप अपने आईडी से हैंड रेज कर लीजिए। जिस सिस्टम से अजय शर्मा सर प्रेजेंट कर रहे हैं वहां से आप प्लीज हैंड रेज कर लीजिए, मैं आपको अलो कर देता हूँ।
Yes, it is allowed.
यस, ओके, ठीक है सर, आप म्यूट करिए आप। अमरीन मैम, आपका चल रहा है माइक, आप प्लीज चेक कर लीजिए।
जी।
ओके, थैंक यू। अशोक जी, आप चेक कर लीजिए। अशोक शर्मा। अशोक शर्मा सर। वी आर रीचिंग टू मैक्सिमम पार्टिसिपेशन लिमिट, जो होता है पार्टिसिपेंट लिमिट होता है 190 पे पहुंच गए। बियॉन्ड 200 देयर विल, जो नए ये रिक्वेस्ट भेजेंगे वो अंदर नहीं आ सकते हैं। तो इट इज रिक्वेस्टेड कि अगर किसी डिवीजन से मल्टीपल डिवाइसेस से आप लॉग इन हो तो प्लीज आप वहां एक ही डिवाइस से कर लीजिए, सो डैट जो बाकी लोग वेटिंग में हैं तो उनको भी हम अंदर ले आ सकें।
Yeah, sir.
फिर आप एक सिस्टम कर लीजिए, आपका इको आ रहा है दोनों सिस्टम से चलने से, उसका ये स्पीकर ऑफ रख लीजिए।
शुरू कर सकते हैं आप?
नहीं मेरे माता थोड़ी मारी गई है मेरे को दिख नहीं रहा था मैं उससे देख रहा था पूरी वीडियो इसको देखा क्या हाल किया था कुछ और भी किया
अमरी मैम, आप प्लीज शुरू कर दीजिए अपना प्रेजेंटेशन।
Okay. Am I audible, Riyasa?
Yes, 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 you are.
Okay, with the permission of the chair, I would like to start. Respected ACS sir and all the participants present, a very good afternoon to all of you. Myself, Amrina Anjum. I'm Executive Engineer in PHE Jal Shakti Water. Deputed by the department to attend a series of workshops on urban water management program with special emphasis on Singapore's approach to water sustainability. The workshop was organized by Ministry of Housing and Urban Affairs, MOHUA, in coordination with Singapore Corporation Enterprise. So the workshop number 1, which was conducted in the month of August in New Delhi, was regarding understanding of urban water cycle, including its treatment and network management and stakeholder engagement through sharing Singapore's experience. As we all know that Singapore is a developed country. We all know Singapore is a developed country with a total population of 734 kilometer land square. Singapore appears as a small red dot when we see it on the globe, on the global picture, with a population of 5.92 millions, which is a high density population, and an annual rainfall of 2200 mm, which is very, very high. Of Singapore, as we see in present scenario, Singapore in early days was placed at 170th position among the list of 190 countries in terms of freshwater availability. The water resources were scarce. The water was a rare commodity, so much so that the last water rationing in Singapore was conducted in the year 1963. The public health condition was disastrous. The sanitation was not very, very good. The floods were very common because of the high annual rainfall, as I already said, and the rivers were already polluted. There were only 2 freshwater sources available with the Singapore. Was built from the Malaysia through a network of system Johar River Waterworks. And the second source of fresh water for Singapore was collection of water, rainwater collection and collection from the catchment, for which not many reservoirs were present in Singapore. And such was the condition that Singapore In Singapore, the water was distributed as like we distribute rice, used to distribute rice in the early days when water was scarce, and it was water rationing was done as early as up to 1963. So on Singapore's International Water Week in the year 2008, the Prime Minister of Singapore said that water is a national priority for Singapore. Water dominated every other policy. Every other policy had to bend at the knees for water survival. So with the coordinated effort of the government as well as the active participation of the public, Singapore over the past 50 years has managed to build a robust and diversified supply of water to meet the rising demand through national taps. Number one, at present, Singapore is getting its fresh water from the local catchments. As many as 15 reservoirs have been constructed in Singapore. The latest one being the Marina Barrage Reservoir, which has been constructed inside the city itself. And it has 3-in-1 benefits of providing protection against floods, providing water supply, and as well as recreational benefits. Number second, the water is still being imported from the adjacent country of Malaysia through a series of network water distribution transmission lines. Then Singapore has managed to use source, and they have developed as many as 5 number of factories for the conversion of what we call the sewage water or the used water into fresh water. After undergoing a series of purification processes, this new water or the used water becomes available as a potable water source for many of the Singapore's population. Then because Singapore is an island country and it has also explored the seawater, and 5 number of desalination plants have been constructed, and recently one of the plants has been commenced in the year April 2022. So Singapore is meeting its water demands from 4 national taps. Earlier it was only from local catchment and imported water. So this is the reason for the success of Singapore's water management plan. The PUB is the Singapore's single national water agency, which is managing the entire water cycle, be it from collection, purification, supply, water treatment, storm water drainage management, treatment of raw water to potable water, supply to industries, construction of desalination plants, collection of used water, and diversion of this rainwater into the sea. Everything is managed by a single national agency in Singapore, which is the PUB, Singapore's Public Utilities Board, which has been established under the Environment and Water Resources Ministry in Singapore. The Singapore's approach to water sustainability has been through hard work and coordinated efforts. They have managed to construct not only a robust but a diversified supply of water to meet the ever-increasing rising demands. Advanced planning, design, and construction of the water supply systems, be it drainage, be it ticketing, micro tunneling, all the modern technologies are being adopted for any site or any sort of construction for the water supply systems. Also, so PPP framework projects have been introduced in Singapore in various water projects, wherein public and private partnership has been encouraged. The expertise of the private partners, along with financing and operational expertise, complemented with the responsibility of the public as a stakeholder, provides them access to safe drinking water and wastewater management. The distribution network loss of weather is being done very meticulously through accurate metering, proactive leak detection, and network management. The approach of Singapore is predictive, I would say, rather than reactive, because they act in a manner so that they predict and apprehend any losses or in the distribution, such that proactive measures are taken and these losses are prevented. Then the legislation and the rules in Singapore with regard to water supply are quite stringent. As much as around $50,000 of fine is charged to a person who is involved in any contractor or any person who is involved in damaging any sort of water supply infrastructure or pipe damage. He is charged with a fine of whooping $50,000 and a jail of 3 years. And let me tell everybody that at present a Singapore dollar is equal to 61 Indian rupees. Then water demand management strategy is also being done, which is again done through the PUB, the Singapore National Water Agency. The pricing and the water tariff is being managed in such a way that it is made mandatory that there is a minimal wastage and judicial use of water. The water metering is done regularly, and certain water efficiency indices have been developed for hotels, institutions, schools, and it has become mandatory for all the institutions to maintain a certain water efficiency index. Otherwise, their license would get cancelled. And every year they get awards for the best institution or the best school for maintaining the best water index. Asset management is being done for all the asset, whether it be the water treatment plants, water reclamation plants, whether it be pipe network. Asset management is being actively done. Then SCADA system is installed in every plant for efficient supervision. The network distribution management is done through good planning and design, which involves sizing of pipes, location of valves, alternate supplies. During construction period, strict supervision and control and workmanship is there. There is a use of reliable pipe material. The use of PU coating, which is polyurethane coating, is done on DI pipes or all replacement projects. Then application of wrapping material is being done for any corrosion preventing. There are good quality material, corrosion resistant connection of are cement line DI steel pipes, then mains with greater than 700 mm dia are cement lined steel pipes. So every precaution and every planning and design and construction phase is being done meticulously so that to ensure the minimal wastage of water and better efficiency. There's a proactive leak detection mechanism which is in place for distribution mains less than 500 mm. Noise loggers are there, pollinators are there, mobile phone sensors are there, permanent leak detection sensors are there. Permanent leak detection sensors are there for monitoring any leakage on a daily basis. Then there are invasive leak detection technology so that there are small leaks and less costly repair to reduce the water loss. There, as you can see, that smart pore sensors are being installed so that you can monitor just any leaks. It has a range of 750 meters. With regard to permanent sensors, they are installed in every transmission main. Then there are invasive technologies wherein you can see under live condition any precise leak detection tool that can be employed, targeted for any sort of water loss. It has a range of 15 kilometers, and such are the active, proactive things that are being done. This is the Johar River Water Works. The water is being imported from Malaysia, which is the adjacent country, which is just adjacent to Singapore, and Singapore was a part of Malaysia, we all know, at one point of time. So at present also Singapore is managing its water supply partly by importing water from Malaysia. The treated water from the Johar River Water Works is pumped to Singapore through major pipelines. Then these are injected into complete complex Singapore water distribution system, and it is distributed to homes and industry through of this island by gravity. As you can see in the pictures, also the Johar River Water Works crosses the causeway, and then it is being distributed inside the country. Then we come to the new water production. In Singapore, we see that the terminology has been altogether changed. Like in India, we call this water as used water, or reclaimed water. But in Singapore, the terminology has been changed altogether, and they called it new water production. After this treated used water or what from this plant, which is called water reclamation plant in Singapore. Then afterwards, it undergoes a series of advanced recycling techniques like microfiltration, ultrafiltration, reverse osmosis. Then finally, ultraviolet disinfection is being done, and new water is being produced, which is very, very good and safe, completely safe, declared by as per WHO standards. It is fit for potable drinking water, and people in Singapore have been seen greatly adopting this new water and using it for every purpose. It has been marketed in marketing is being done on a great scale, and they have greatly adapted this new water. This is because of the motivation and the public awareness and programs, and you can say people have greatly adapted it. These are the series of the various processes which this used water, after it is being treated from any sewage treatment plant, which is called water reclamation plant in Singapore. After undergoing primary, secondary treatment in these plants, this used water is then undergoing micro filtration, wherein this is passed through 0.2 micron suspended solids are being filtered out. Then this water is being conducted through these hollow fibers, and any impurity up to a size of 0.2 microns gets attached to these hollow fibers. Then again, it is subjected to another process which is called reverse osmosis, wherein under high pressure, this water is passed through semi-permeable membranes, and particles as small as 0.0004 microns are removed and trapped in these membranes. Then finally, the water undergoes UV disinfection through UV light, and it becomes fit for drinking purposes. Then in Singapore, because land is a constraint, as the country is very, very small with an area of total 734 square kilometers, the treatment technology becomes a difficult decision for them to choose, because land is a constraint. You cannot be constructing large treatment plants and large reservoirs everywhere, because land is a constraint there. So a process strategy has been developed wherein the process is being selected after undergoing various checks, like the capacity of the plant is one parameter, and the second parameter is the availability of capacity of the plant is greater than 50 mld and the land is available. Then you can go for conventional treatment of this sewage or sewage used water through primary clarification, secondary conventional biological nutrient removal, and then biosolid treatment, and finally deammonification. But if your capacity of the plant is greater than 50 mld and the land is not available for construction, then you have to adopt the process number 2. In process number 2, we are removing the conventional secondary treatment with an MBR technology provided with IFAS, which is integrated fixed film sludge technology, which actually reduces the space, because the secondary clarification is done in single tank only, and so that sludge generation takes place quickly, and we don't require any secondary or any huge clarifiers for any sludge digestion. Similarly, for plants less than 50 mld capacity, again, when the land is available, then you go for conventional treatment processes. But when the land is not available, obviously, you have to go for the expensive technologies like MBR technology, and accordingly, the process for a water reclamation plant is a design process is selected. Then for the advanced recycle technology, wherein the water is converted into potable water, again, it has been found that the RO-based treatment drains are most costly and energy intensive as compared to the ozone bioactivated carbon UV disinfection, especially at the inland locations where reverse osmosis concentrate disposal is difficult and can be very expensive. This is how the selection of the technologies is being done. This is a schematic diagram showing the 4 treatment processes, as I already discussed, wherein you can see in group 1, we have conventional technology used in sewage treatment or water reclamation. Then we go for advanced recycling water treatment plant. And then in group number 2, where there is a land constraint and the capacity is greater than 50 mlt, we go for bioreactors with MBR technology, and followed by the same advanced recycled water treatment plant. Then treatment process number 3 and treatment process number 4, wherein after primary, secondary, and tertiary treatment, accordingly, the recycled water is being produced. This is an overview of the construction of how the construction of the conveyance systems, any wastewater treatment pipeline or any water system pipeline transmission mains are trenchless technologies. Trenchless technologies like pipe jacking or micro tunneling is being adopted against the open cut excavation, because in Singapore, as land is a constraint and not much working space is available for these constructions, so they adopt such kind of technologies, which although are typically faster, but they are higher in cost with less disturbance and less carbon footprint on the environment. Also since less space is required. But however, the ground condition may require stability, which is being done by certain grouting techniques. And obviously there are many as well. This is a typical pipe jacking or a tunnel boring machine, which is typically used for pipe jacking or micro tunneling. The stages are that wherever there is a site of construction, you have to construct a launching shaft and a retrieval shaft. Then the TBM is transported to the site in a disassembled form. It is assembled at the site itself, and then it is launched inside the launching a shaft, and then the construction of an excavation of the tunnel is being done. Again, the TBM is retrieved at the retrieval shaft. Again, it is transported back. This is the drainage scenario of Singapore. As I already said, that Singapore is receiving a rainfall of more than 2200 mm per year, which is double to that of what London is receiving. So Singapore operates separate systems for drainage as well as sewers, and rain is conveyed to the sea to prevent flooding. As I already said, Singapore has various space constraints. From the pictures, we can see that a major stormwater infrastructure has been constructed in Singapore, and certain flood detention buffers have also been constructed. As you can see, during the storm event, this area acts as a buffer, or a flood storm event is over, the same area acts as a beautiful garden or a green space with water, and people can go for any recreational activities. So PUB, which is the single water agency in Singapore, launched the Active Beautiful Clean Waters program in the year 2006 with an initiative to transform Singapore into a city of gardens and water. This was the problem with the construction of a sewerage system in the past, because Singapore is a constraint in Singapore. So to eliminate any excessive land usage, deep tunnel sewerage system concept was developed, wherein how this deep tunnel sewerage system helped was that need of any intermediate pumping stations in between was eliminated, and the whole of the sewage or the stormwater drainage could be transferred through gravity into a single compact water reclamation plant, and then either it was treated or simply effluent was disposed of into the seawater. These the international standards for recycled water was also as per guidelines values, and in which more than 179 parameters are being tested. These guidelines and standards are quite stringent, and after undergoing these tests, only then the water is being supplied to the public. Now in India, when we see the water recycle status in 2021, the total volume of used water generated by the household in India was around 72,368 mLTs. Out of this amount, the estimated infrastructure capacity for treating used water is only 44,000 in India, which is around 31,841 mLTs. As per the inventory of the Central Pollution Control Board, only a small portion of used water is treated water is being reused in India. That is less than even 1,000 mLDs. That is 3% of the treated used water is being reused for any valuable purpose. And this treated water is almost entirely discharged into water courses, irrigation parks, lawns, or public places. It's reused for any non-potable purposes such as crop irrigation, industrial process. Charge is still relatively uncommon. So globally, India is ranked as the 30th most water-stressed country. Water scarcity necessitates its diversification to alternative water supplies. After Qatar, Israel, Lebanon, Iran, Jordan, Libya, Kuwait, which you can see all Gulf countries, Saudi Arabia, UAE, India ranks at number 13. It is estimated that if 80% of the urban used water could be collected and treated by 2030, there will be a total volume of 17 billion cubic meters per year. And out of this 17 meters, if it is captured and treated safely, almost 75% of the projected industrial demand can be met, and almost a quarter of the total projected drinking water requirements in the country can be met. And this can help in reducing the demand of the fresh water. These are the certain central laws and policies which are governing the water sanitation and water used water in India. The Water Prevention Pollution Control Act was enacted in 1974 to maintain and restore the wholesomeness of the aquatic sources. Then the Ganga Action Plan in 1986 was launched improve its quality. The Environment Protection Act is 1986, which is an umbrella legislation designed to provide a framework for central and government coordination along with the states. This act applies in principle to every establishment, agency, individual for discharging any pollutant into the environment. This is a scenario of state policies in treated used water. 12 states in India, which include our state of Jammu and Kashmir, have safe reuse of treated water policy, either approved or at an advanced stage of drafting, which include Karnataka, Chhattisgarh, Tamil Nadu, UP, Maharashtra, and West Bengal also. Majority of state policies prescribe mandatory usage of industrial water within a certain distance from a used water treatment plant to be not to be disposed of directly into the water. ULBs have set targets ranging from 20 to 25% of TUW, treated used water, replacing fresh water usage in India initial years. For some states, the target varies by size, like states in Gujarat and Haryana prescribe a higher targets in subsequent years to achieve 100% reuse by 2030, and Karnataka prescribes 50% reuse by 2030. These quality standards in the state policies are limited to CPCB and state pollution control discharge standards. Thank you everyone for the patient here. Welcome for any questions. Am I audible, sir?
Yes, you are. Yes, you are. Any questions from anybody?
Riya Sab, this is Director Planning here. Small query and suggestion also. Once we have studied the Singapore model, it's appreciated that our executive engineer has reached to such a level. My query is that presently the Amrut DPRs are being submitted to the Housing and Urban Development Department. If we can maintain the same standard of the Singapore and the good improvements or the best takeaways from Singapore model can be replicated in Srinagar city. The efforts of the predecessors are appreciated. We have Tangnar scheme, Suknag scheme, and other schemes which were envisaged 10 years back. It seems that for next 5 to 10 years, we are comfortable. But to raise the standards to the next level and to have the legacy continued in the future, we should use these technologies in the Amrut DPRs.
Absolutely, sir. That is why Singapore model has been discussed, and in fact, everybody workshop from all parts of the country were quite impressed with the Singapore struggle and how they their approach towards water sustainability. We just required to follow what Singapore has adopted, and as I already said that India is at number 13 so far as the water availability is concerned. So we are also a water stressed countries, though not in Kashmir at present, but then adopting this approach would be of great use and always helpful.
Am I audible, Riaz?
Yes, sir. Yes, sir. Very clear, sir.
Am I audible, Riaz?
Yes, sir.
Riaz, can you hear me?
Yes, sir. Yes, sir. Yes, sir. Clearly, sir. Clearly.
All right. Since the other one is still getting connected, I just wanted to make a few quick comments. आप मुझे सुन पा रहे हैं?
Yes, sir. Yes, sir. You are audible.
अनवरीन, आप सुन पा रहे हैं मुझे?
Yes, sir. Yes, sir.
या ओके, इसको स्विच ऑफ करिए. इससे कंफ्यूजन क्रिएट कर रहा है. थोड़ी देर के लिए रख दीजिए, कुछ बात करने दीजिए. अभी मत करिए, उससे we are unable to talk also. Just leave it. Because वो कनेक्ट हो जाएगा तो उसमें एको होगा ना. जी. अभी एको मत करिए. See, I hope everybody who's connected is watched this entire presentation carefully. It has taken some time to Singapore to understand the importance of managing water. Their disadvantage is that they do not have water as freely available as it is available to us. And we are fortunate to have fresh water available to us. And probably that's why we have profligacy is now part and parcel of our living style. All the water that we throw out, use. The recycling of water is hardly anything worth speaking of. Particularly, there are a few things which some parts of the country have already done. For example, unfiltered water supply, which is used in gardens, etc. So if you happen to go to Delhi and go around, then you'll find a specific smell emanating from all those places which are public gardens. Why? Because that water, and I think that's a huge 9 mgt supply, or even more now, the CPWD manages it. 10 mgts I'm talking about to 2005. So they manage an unfiltered water supply, which is something which is needed to be, which is requirement of Jammu and Srinagar also, because people have huge lawns, and then they use this water that we are supplying for the purpose of watering those lawns also, or for the plants also. Ideally, it should be the unfiltered water supply which should be used. Unfiltered does not mean that it will contain bacteria, but unfiltered would mean that it will remove all those kind of impurities which can harm the plants or harm the general environment, but will not get into chlorination and many other things. Or chlorination only to the extent that it removes the contents, the pathological content which is there. So this is one area which is certainly required to be looked at. Number two, right now we may be water surplus. Right now maybe we are in a position that we can get whatever water we want. But as we proceed, and this is one single country, there will be a requirement. You must have read reports, all of you must have definitely, and if you're not, please go through the websites of the Government of India, of the various international organizations. You will realize that country as a whole, we are water scarce. And in times to come, water, if it is our asset, we will have a right on it, but we can also get a huge amount in return for it. For example, electricity. Now, in power, we have estimated that we have 20,000 megawatts of energy. That 20,000 has been more precisely defined as 15,000 megawatts approximately by way of small and medium power plants and big ones. This 1500 megawatts is essentially hydroelectric. And this hydroelectric power is something which we can put in the grid, particularly during peak hours. It results into huge advantages to the state, to the UT. So we need to understand that we cannot be wasteful about our water resources. How will we make best use of it and make ourselves an economic powerhouse in the country is a different matter. It's a matter, as the time will tell, in times to come. But we need to think of practices where our water management practices does not waste water at all, and retrieve whatever water we can. So I'll be very happy in case any of the officers who are there connected can take up this task, or can think of going specifically in the directions. And let us understand, today is the time of specialization. So some of you who might be interested in urban water supplies or in urban sewage handling methods, etc., they should, or if you have not made such a choice, particularly the younger people who are there, then you should look into that. And if a specialization comes, then let me assure you that Secretariat will be definitely very supportive of people who want to specialize into certain fields. Of course, you will have postings all across, get to learn about Jal Shakti Department's various wings over a period of time, next 10-15 years. But by that time, you should think of specializing in certain branches. And therefore, that's why I suggest, with urbanization going at the pace it is going, urbanization is going, speed at which urbanization is taking place is very fast in JNK also. Given that, there is going to be increasing need for people who do urban water management. So that's why the importance of the presentation which is there cannot be overstated. I would request Anbarin, since you are in regular, you are attending workshops in Government of India, there are certain visits which will ultimately you will have to Singapore also. We would expect that as you go along with the GOI process, you keep on updating this workshop series, and if you can, give a context of JNK in this regard. What is the actual recycling that we are doing? What is the unfiltered water supply we are doing? What is the kind of, like you wrote, 17 BCM is the water which is there in Singapore. What is the BCM which is generated here? All this data is available in public domain also, as well as MD JJM's group also has it. So please give a context to this thing, or take up water supply schemes. Let's say Srinagar water supply, you are in Waterworks division, and try to juxtapose it with that. That will give more clarity to the officers. Thank you.
Sir. Thank you, sir. Thank you.
Yeah. We can go on to the next presentation.
Yes, sir. Sir, we have now second presentation from Engineer Ashok Sharma, sir, who is Executive Engineer in PHE Udhampur, sir, who will be presenting his inputs on some interventions he has made, sir, while implementing Jal Jeevan Mission. some cost effective and time effective interventions, especially the filtration plant, sir. He's making a presentation, sir. Mr. With the permission, sir, may I request Engineer Ashok Sharma, please start your presentation.
Good evening for the ACS sir and all the members who have joined the meeting. Sir, today I am going to present the filtration plant oblique filtration gallery.
Ashok sir,
Yes,
sir, please आप जो presentation है इसको full screen mode में ले आइए. वहाँ right corner में bottom में एक full screen ये है टैब है, उस पे क्लिक करके. हाँ, please. Okay, thank you.
Am I audible, sir?
Yes, yes, you are, sir.
Good evening for the ACS sir and all the members present in the meeting. Myself, Executive Engineer Ashok Kumar Sharma, present in Udaipur Division. Sir, today I am going to present about the filtration gallery oblique filtration plant, which we have designed after taking a lot of challenges from the field, particularly the field. Sir, let me explain that Udaipur district, as we all know that it is mostly of hilly areas. On the whole, we have 159 number of schemes. And when we talk of the filtration plants, we have 38 number of rapid sand filtration plants and 214 number of slow sand filtration plants, which will remain the major challenge for this division to in regard of tendering and the execution of the same. When we talk of the slow sand filtration plants, sir, actually major problem that same kind of design was given by the in the DPRs. जैसे हम उधमपुर की बात करें या जम्मू की बात करें या सांबा की बात करें या कठुआ की बात करें, तो सेम डिजाइन ऑफ स्लो सैंड फिल्ट्रेशन प्लांट जो कि डीपीआरस में था. तो जब मैंने नवंबर 16 को यहाँ ज्वाइन किया, तो दिस वाज आल्सो द मेजर चैलेंज फॉर मी कि उधमपुर यहाँ पे हमारे पास जो ओल्ड डिजाइन का फिल्ट्रेशन प्लांट है, जिसमें हमें मोर देन 2 कनाल्स ऑफ लैंड चाहिए थी उसके एग्जीक्यूशन के लिए, और जब अब वो प्रपोजल जब वो 214 नंबर ऑफ फिल्ट्रेशन प्लांट्स की हमने टेंडरिंग की, तो उसमें रिस्पांस इवन 10 मंथ्स तक उसमें कोई रिस्पांस नहीं आया. तो जब हम लोगों ने उसको एनालाइज किया कि उसमें मेजर चैलेंजेस क्या हैं, तो हमने देखा कि उसमें जो पहले नंबर 1 मेजर था कि 2 कनाल्स ऑफ लैंड अवेलेबल ही नहीं थी पहाड़ी इलाके में. अगर कहीं अवेलेबल होती तो उसमें वर्क कटिंग बड़ी ज्यादा थी, उसमें कटिंग इतनी ज्यादा थी कि प्रोटेक्शन वर्क बड़ा इन्वॉल्व हो रहा था. फिर हम जो और डिटेल एनालाइज करने पे ये देखा गया कि टर्बिडिटी जो है, क्योंकि ये वेजिटेशन एरिया है यहाँ पे पूरा उधमपुर डिस्ट्रिक्ट को अगर हम देखें पहाड़ी इलाका, तो यहाँ वेजिटेशन और टर्बिडिटी जो है वो इसमें बड़ी कम है. तो एनी हाउ इस चैलेंज को लेके हमने जब कंसर्न जेईस को या अपनी टेक्निकल टीम को जब हम लोग बैठे, तो हमने एक एनालाइज किया कि क्यों ना जितने भी हमारे पास जो बचे हुए हैं, इसमें हमारे पास जो 194 नंबर ऑफ फिल्ट्रेशन प्लांट्स जो बचे हुए हैं, इनकी टर्बिडिटी को सबसे पहले क्यों ना एनालाइज करवाया जाए कि इसकी टर्बिडिटी कहाँ फॉल करती है, कि क्या वेदर ओल्ड डिजाइन ऑफ फिल्ट्रेशन प्लांट्स की जरूरत है. और क्योंकि इतना एरिया हमारे पास अवेलेबल नहीं है, तो पिछले 10 से 12 महीने तक इसमें कोई रिस्पॉन्स नहीं आ रहा है. तो हम लोगों ने इसे एक नया डिजाइन देने की कोशिश की. तो उसमें हम लोगों ने जब लेबोरेटरी की हेल्प ली, तो हमने देखा कि इसमें टर्बिडिटी जो है वो बड़ी कम टर्बिडिटी है. तो पूरे 214 नंबर ऑफ जो स्लो सैंड फिल्ट्रेशन प्लांट्स थे, उसको डिवाइड किया हम लोगों ने फ्रॉम टर्बिडिटी पॉइंट ऑफ व्यू से. तो स्लो सैंड फिल्ट्रेशन जो ओल्ड डिजाइन में वो 20 नंबर फॉल किए, और जीरो टर्बिडिटी में हमारे पास 70 नंबर फॉल किए, और लो टर्बिडिटी में हमारे पास 214 नंबर ऑफ 124 नंबर ऑफ कॉल किए। तो ये टोटल जो फिगर थी, जब हम लोगों ने इसे एक नया डिजाइन देने की कोशिश की, तो उसमें हम लोगों के पास सबसे जो मेजर चैलेंज था कि फिल्टर मीडिया कौन सा इस्तेमाल करें, क्योंकि जो ओल्ड डिजाइन फिल्टर मीडिया है दैट रिक्वायर्स अ लॉट ऑफ एरिया। तो इसमें हम लोगों ने एक डिजाइन, क्योंकि चीजों को यहाँ पे सोच के एक डिजाइन क्रिएट किया, और अकॉर्डिंगली हायर अथॉरिटीज की डायरेक्शन पे हम लोगों ने आईआईटी की कंसल्ट किया, आईआईटी को कंसल्ट किया और डिजाइन को वेटिंग के लिए आईआईटी में भेजा। तो जब आईआईटी में हम लोगों ने डिजाइन को भेजा, तो वहां पे भी इसी पे जो सीपीएचयू पे जो मैनुअल ऑन वाटर सप्लाई एंड ट्रीटमेंट है, तो इसमें सबसे पहले हमने वहाँ एक 7.6.4.4 जो जेजेएम के गाइडलाइंस थे वहाँ उसे स्टडी किया। फिर हमने वो मैनुअल 7.6.5 स्टडी किया। जब 7.6.4.4 स्टडी कर रहे थे, तो हमारे पास फिल्ट्रेशन रेट्स एंड फिल्ट्रेशन क्वालिटी का जो चैलेंज था वो था। तो 7.6.5 स्टडी किया, तो उसमें मल्टीमीडिया फिल्टर जो है वो उसमें एप्लीकेबिलिटी उसमें हमें मिली। ओवरऑल एनालाइज करने पे हम लोगों ने जब इसको शेप दी एक नए डिजाइन को, तो वो हमारे पास सबसे जो टॉप लेयर थी उसमें हम लोगों का एक्शन जो था वो रिवर्स रहा, क्योंकि जो एब्सोल्यूट जो पुराने डिजाइन ऑफ फिल्टर्स हैं, अगर हम उसको एनालाइज करें तो फ्लो सैंड ऊपर पड़ती है, नीचे स्टोन ग्रिट्स पड़ते हैं, या नीचे बोल्डर्स पड़ते हैं, तो वहां से जो वाटर है वो फ्लो करता है। तो लेकिन यहाँ पे हम लोगों ने इस पे थोड़ा रिवर्स रखा। हम लोगों ने ये एनालाइज किया कि अगर हम लोग इस पे टॉप पे अगर फाइन ग्रेवल रखें फ्रॉम 2 to 5 mm और सिलिका सैंड रखें नीचे, इसका साइज 1.4 to 2 mm रखें, और एंथ्रासाइट कोल का जो पर्टिकुलर हम लोगों ने इसमें इस्तेमाल किया, जिसका मेन आज की डेट में रोल है टू इंक्रीज द फिल्ट्रेशन कैपेसिटी ऑफ दिस। तो क्योंकि हम सब जानते हैं कि एंथ्रासाइट कोल जो कि जिसकी स्पेसिफिक ग्रेविटी 1.4 है, एक यूनिक पोरस स्ट्रक्चर है, प्रोवाइड्स ए हाई सरफेस एरिया फॉर एब्जॉर्प्शन एंड नॉट फॉर अब्जॉर्प्शन। तो क्योंकि एक इसकी क्वालिटी है एब्जॉर्प्शन की, तो ये वाटर को अटैक करता है टुवर्ड सरफेस और इसकी जो फिल्ट्रेशन कैपेसिटी को इंक्रीज करता है। तो हम लोगों ने जब उसको सीपीएचओ नॉर्म्स में स्टडी किया, तो ये पाया कि इसकी फिल्ट्रेशन कैपेसिटी जो है वो that can be increased up to 24 cubic meter per hour per meter scale। तो वो नॉर्मल जो थी वो 16 क्यूबिक मीटर पर मीटर स्केल पर आवर थी, क्योंकि अगर प्री ट्रीटमेंट प्लांट उसमें रखें तो जिसके कारण उसकी कैपेसिटी जो है वो इंक्रीज हो जा सकती थी। अब हमें ये क्वेश्चन तो क्लियर था कि जो फिल्ट्रेशन कैपेसिटी जो कि स्लो सैंड फिल्ट्रेशन प्लांट्स जो कि हम डिजाइन आज तक हमने दिए हैं, उसकी मैक्सिमम कैपेसिटी जो है वो 5000 गैलन पर आवर हिसाब से है। तो एनी हाउ कैपेसिटी का कोई इशू नहीं रहा। तो बाद में जब एंथ्रासाइट कोल का जब हम लोगों ने इसमें चूज किया, तो हम लोगों ने उसकी डिजाइन जो है वो एक हमारा थ्रू हुआ है। और अगर हम ये ड्राइंग को एनालाइज करें तो इसमें हम देखेंगे कि पहले हमारे पास सबसे पहले जो एंट्री ऑफ वाटर है वो फर्स्ट चैम्बर है, जो इनलेट चैम्बर है, उसमें भी हम लोगों ने सेडिमेंटेशन का प्रोविजन रखा हुआ है। और फ्रॉम दैट द वाटर विल फ्लो टू सेकंड चैम्बर। यहाँ पे अगेन सेडिमेंटेशन का प्रोविजन यहाँ पे रखा है, और जो सिल्ट है या एक्स्ट्रा सिल्ट है वो नीचे से हम लोग इसमें निकाल सकते हैं। देन वाटर विल फ्लो टू लास्ट चैम्बर वेयर वी हैव केप्ट द फिल्ट्रेशन मीडिया। और फिल्ट्रेशन मीडिया का जो प्लेसमेंट है हमारी, दैट इज द रिवर्स, दैट इज फ्रॉम हाई साइज एट द टॉप टू लोअर साइज एट द बॉटम। इसका जो नीचे का जो स्ट्रक्चर हम लोगों ने इसमें डिजाइनिंग में दिया वो सेम था जैसे कि ओल्ड डिजाइन फिल्ट्रेशन प्लांट्स पे था। अब इसमें हमें जो प्रैक्टिकली जो जब एग्जीक्यूशन हम लोग कर रहे थे, तो हमें प्रॉब्लम जो बेसिक वहां पे दिखी कि जो एंथ्रासाइट कोल है, अगर हम उसका साइज 1.4 mm जैसे हम ले रहे हैं, तो वो एंथ्रासाइट कोल वाटर फ्लोइंग के साथ नीचे आ जाएगा। उसके लिए हम लोगों ने थोड़ा सा अब इस डिजाइन में, क्योंकि वो जोशी साहब और वर्मा साहब से मेरी डिस्कशन हो चुकी है कि ये लास्ट स्टेज जो है, हम लोगों ने जो थिकनेस ऑफ दी एंथ्रासाइट कोल जो कि 45 सेंटीमीटर हम लोगों ने रखी है, तो मैंने उनको यहाँ से एक आइडिया दिया है कि सलाह दी कि हम क्यों ना इसको लास्ट वाली लेयर को जो बॉटम मोस्ट लेयर है उसको हम बाइफरकेट कर लें 15 सेंटीमीटर एंड 30 सेंटीमीटर। जो 15 सेंटीमीटर जो बिल्कुल लोएस्ट पे रखें, ताकि और उसका साइज जो एंथ्रासाइट कोल का है वो रखें 8 mm to 10 mm, और जो उसके टॉप उसी के साथ जो सरजाइनिंग जो टॉप वाली लेयर है उसको हम रखेंगे 30 सेंटीमीटर, जिसका साइज होगा 1.4 mm। उससे हमें एक बेनिफिट होगा कि जो वेस्टेज ऑफ एंथ्रासाइट कोल जो कि बड़ा ग्रेडेड नीचे जिसके आने के चांसेस है वो चांसेस कम हो जाएंगे और हमें प्योर वाटर जो है वो नीचे से मिलेगा। तो ये हमारा जो एक डिजाइन था, हम लोगों ने यहाँ डिवीजन से जो आईआईटी को वेटिंग के लिए भेजा, और वहां पे वेटिंग के बाद हमें वर्दी चीफ इंजीनियर साहब ने इसकी परमिशन दिया एग्जीक्यूशन के लिए। तो आज की डेट में जब हम लोगों ने ये नया टेंडर लगवाया, तो क्योंकि कॉन्ट्रैक्टर्स की नीड में एक तो चीज हमें क्लियर थी कि कॉन्ट्रैक्टर्स जो है वो लैंड की अवेलेबिलिटी नहीं थी हमारे पास, तो 2 कनाल लैंड पहाड़ी इलाके में नहीं थी। तो जब ये नया डिजाइन जो हम लोगों ने दिया, जिसमें हमारे पास 40% ऑफ दी सेविंग ऑफ द लैंड है, और उसकी कॉस्ट अगर फाइनेंशियल हम उसकी देखें, फाइनेंशियल सेविंग्स ड्यू टू अडॉप्शन ऑफ न्यू डिजाइन, जैसे हम देखते हैं कि हमारे पास अब कैपेसिटी जैसे ओल्ड डिजाइन पे देखें 1000 जो गैलन्स की कैपेसिटी थी, तो उसमें 134 नंबर था, तो अमाउंट उसका 28 लैक्स बनता था उसका। तो 2000 के थे 30 नंबर थे, वो डिजाइन के 41 लैक्स था। बाकी 3000 के 21 थे 49 लैक्स था, 5000 के 8 थे 61 लैक्स था। तो ओवरऑल में हमारे पास ये टोटल कास्ट अगर ओल्ड डिजाइन की देखते तो 64.99 करोड़ कास्ट बन रही थी। लेकिन क्योंकि हम अब काफी ये डिजाइन इसमें काफी आगे निकल चुके हैं, कंस्ट्रक्शन हो चुकी हैं, आज की डेट में हमारे पास 49 ये कंप्लीट हो चुके हैं, वी आर गोइंग टू कमीशन दैम, वी आर गोइंग टू पुट फिल्टर मीडिया देयर। जो द लास्ट पॉइंट है वही लास्ट की लेयर की, क्योंकि ये अभी थोड़े दिन ही कंस्ट्रक्शन के बाद की प्रॉब्लम राइज हुई है, और इसमें मैं अप्रूवल चाहूंगा एक बार फिर आईआईटी का। तो अगर हम न्यू टाइप ऑफ फिल्ट्रेशन गैलरी जो हमें डिजाइन जो हम लोगों ने यहाँ इसका डिजाइन दिया है, तो हमारा डिवीजन जो गया जो हमने वो जीरो टर्बिडिटी वो 70 नंबर निकले, जिसकी हमारी कास्ट 4.34 है, क्योंकि ये स्लो एंड फिल्ट्रेशन प्लांट्स जो है उस जगह पे दिए गए हैं जहाँ पे पहाड़ी इलाके में बिल्कुल साफ सुथरा पानी था, बिल्कुल नेट एंड क्लीन वाटर, और जिसमें फिल्ट्रेशन प्लांट्स की जरूरत ही नहीं थी हम लोगों को। इवन बहुत से ऐसे चश्मे हैं पहाड़ी इलाकों में जहाँ से दूर दूर से लोग पानी लेने आते हैं, और उन चश्मों की एक खासियत है कि वो बड़ा अच्छा पानी जो है वो प्रोवाइड करते हैं। तो जब उनकी टेस्टिंग की गई तो वो टेस्टिंग में बिल्कुल फिट पाए गए, इसीलिए हम लोगों ने जो टोटल ऑन दी होल इसमें जीरो कैपेसिटी के 17 नंबर हमारे निकले हैं, उसके 4.34 के अमाउंट के हिसाब से जब हमने कास्ट एनालाइज की तो 303 लैक्स हमारी कास्ट बनती है। लो टर्बिडिटी का बाकी जो भी जिसकी जो टर्बिडिटी 1 to 5 जो परमिसिबल लिमिट्स होती हैं, उसमें जब हम लोगों ने देखा तो हमारा डिजाइन जो नया डिजाइन था उसकी 18 लैक्स कास्ट थी, तो उसके 22.3 करोड़। एनी हाउ जब न्यू डिजाइन टोटल देखा तो 25.35 करोड़ हमारी कास्ट बनी है। अगर सेविंग की बात करें तो 39.63 करोड़ की सेविंग है। खैर सेविंग एक पॉइंट नहीं है, लोगों को अच्छा पानी देना है, लोगों को वाटर क्वालिटी के में कोई कंप्रोमाइज नहीं किया जा सकता। लेकिन हम लोगों ने ये ऑब्जर्व किया, हमने देखा कि हमारे नए डिजाइन ने जो कि जब इसकी टेंडिंग के बाद हमने देखा कि कंस्ट्रक्शन भी इजी थी, एरिया कम था, जिसमें फॉरेस्ट लैंड इन्वॉल्वमेंट ज्यादा नहीं थी, तो हम लोगों ने को काफी उसमें इजी हुआ। तो जिसके कारण हम लोग आज की डेट में हमारे जो 194 जो जितने भी कंपोनेंट्स इस पे तमाम पे काम चल रहा है और बड़ी तेजी के साथ चल रहा है, और जिसमें 49 हमारे पास कंप्लीटेड है, और इसकी कमीशनिंग का हम लोग वेट कर रहे हैं। थैंक यू सर, थैंक यू। एनी क्वेश्चन फॉर मैनी सर? Sir, any question from any side? Any my counterparts?
Riaz, are there any questions from anybody?
Sir, I don't think so, sir.
All right. It seems that we'll have to change the time of holding this particular thing to Thursday, where we have more energetic participation from everybody. We can think of keeping it on Thursday, 4 o'clock, so that Saturday everybody seems to be in a rush to enjoy the Sundays. In any case, Ashok, very good presentation.
Yes,
you have brought out some very important aspects. What is specifically something that I wish to point out here is that while it is easy to have a challenge and then get stuck with fixed ideas, here there was an attempt to get into, not attempt, it was an effort made to try to get to bottom of the things, understand that why nobody is coming in tenders. Why is it? Is it something which is critical to whatever our objective is? The objective is to give clean water. So if the land is not available, is it possible to make something in less amount of land? For example, even if it was turbid water, would it have been possible to have a split kind of filtration system which uses the available terraces? Just an example. So
Sir, we are
here an additional aspect came in, and there it was seen that there is low turbidity at places. So it's not just the money which has been saved. What is required to be understood is that while there are standard designs, it does not mean that your innovativeness or your ability to find out answers where probably others have not applied themselves, that is very much there in the day-to-day working of the government systems. This typical attitude that government means that you simply toe the line of whatever and remain oblivious to what are the opportunities in the rest of the world, what are the developments taking place. ऐसा नहीं है. Government gives you an advantage of actually trying innovation. Only thing is, obviously, since you are working in a system which has a huge impact, and you are not playing, you have the responsibility of taking care of the lives of a number of people. So therefore, there are mechanisms in government where the vetting of a particular design will take place. For example, in this case was IITs, जहाँ पर IIT में जाके इन्होंने अपनी डिजाइन को वेट करवाया. तो मेरा आप लोगों से इतना सा कहना है कि जिस दिन से यहाँ पर एक सॉल्यूशन पता लगाया गया सर्कमस्टांसेस को देखते हुए, इसी ढंग से अपनी अपनी जॉब्स में कोशिश करें that you can apply such things. Of course, the saving is always a welcome thing. यहाँ पर 40 लाख के करीब 40 करोड़ के करीब सेविंग हुई है. I would like to inform everybody, because here Jal Shakti के सारे लोग connected हैं. You must have seen that press conference in which after the allegations were leveled by one of the previous secretaries of Jal Shakti that there is a lot of malafide or a lot of flaws in tendering or administrative approvals नहीं हुए वगैरह वगैरह. बोला गया 11,000 करोड़ के पाइप्स को खरीदा गया, and all those kind of allegations, wild allegations leveled. And when I had given the press conference, then I had gone into details of various things. I would suggest look at those press conference, look at that. You will get to know a lot about the delegation. You will get to know a lot about other things. Why I'm specifically mentioning it here is that it is these kind of innovations which have been done by others also. And here is an opportunity for us to do it. For example, in Kashmir, where the overhead tanks was becoming an issue, a solution was found where it was decided that on the pattern of railways, FRP tanks. Mr. Kohli is here with me. He tells me that has been brought about. This FRP tanks based OSTs बनाए गए. So there are ways and means. There are solutions which are there, and these solutions depend on our ingenuity. All right, I'll go ahead with the next presentation since there is nobody else who has a question. Third one, please go ahead.
Thank you, sir.
Ajay Sharma. Yes.
Sir, I'd like to say. I'd like to say something, sir. Yeah. Sir.
Yeah, Mr. Kakru, please go ahead.
Sir, I just wanted to say something about the slow sand filtration plants, because generally, sir, I joined a little late, but somehow I got the hang of what he's trying to say. One of the main problems is that the filter media gets, it gets spoiled very easily, and filter media being very expensive. So we kind of then we reach a stage where the filtration plant itself gets defunct. So one of the things that probably the department needs to do is to develop a standard operating procedure for operation of these filtration plants. Like in hydropower plants, what we do is when the water has got high turbidity post rains, they generally bypass they do not let the water flow into the channels so that the turbines don't get damaged. In the similar manner, we can think of something. This is just a wild thought that during high turbidity times we can try to bypass the filter beds so that the filter beds do not get choked very easily. And
Very
in
valid.
that case, how do we,
Very valid.
in that case how do we supply water to the people is something that has to be thought about.
Yes, I will
Just
I
about
will
it.
interrupt you here because
Sir.
the times of very high turbidity in case of flash floods, etc., are not for a period of an entire day. It is for a period of 2 hours, 3 hours, a limited period of time. It is possible that after that, or if their sedimentation tanks are not sufficient, if there are alternative ways which are possible. So, in fact, this idea is something which you need to develop further. And I think MD JJM also, who is connected, as well as the two chief engineers of PHA and others of other irrigation, etc. Plus, Mr. Kakru will take your help. We are of the view that there is a separate DIQC of Jal Shakti department which is coming in, which is going to be established in some point of time. We are working on that because PWD has set up its own DIQC, and there is it's move in a direction where Jal Shakti का specific DIQC अगर होगा designed inspection and quality control, then it will be possible to address various aspects of Jal Shakti, not just related to water supply, not just related to irrigation, but not just hydraulic structures. It could be something else also. A study of sedimentation, a study of various things. And this DIQC is also going to be the one which will look into specific contracts meant for Jal Shakti kind of things. And similarly, then it comes to what Mr. Kakru just now mentioned is SOPs. SOPs for finding out ways and means by which we extend the life of various kind of infrastructure created by us. So, Mr. Kakru, the point very well taken. And in fact, I hope Director Planning, you will make a note of this. And even while we wait for the DIQC to come into being, Hitesh is also connected, I presume. But even while we wait for that to happen, we can immediately constitute a committee. You can consult Mr. Kakru and other chief engineers and MD, etc. Think of a committee which can come out with an SOP under the JJM framework, where we look at how the turbidity and water flow, etc., and the capacities and how they can be linked with kind of filter, so that filtration plant, so that we can have longer periods of filtration, longer periods of life of the filtration plants. I hope Iftikhar sir, ये इसमें आपकी मदद रहेगी, तो we'll be able to do it.
Sir, may I say yes, sir?
Sir.
Yeah, yes, बोलिए.
Sir, Mission Directorate is already in the process of formulation of SOPs for this operation and maintenance of the water supply scheme, sir. So, usme, sir, special focus has been given to these operation of slow sand filtration plants, sir. The SOPs are in the final stage, sir. Hopefully, sir, within a month, we may be able to finalize the draft of these SOPs. That is a manual, sir, for operation and maintenance for field engineers as well as the field staff, sir. तो उस चीज में सर उस मैनुअल में इस चीज को ऑलरेडी रखा गया है सर.
ठीक है, जरा देखिए, अगर जरूरत है तो कमेटी भी बनाइए, नहीं बनाना है तो कोई बात नहीं, आप जिस दिन से अभी एसोसिएट कर रहे हैं, आई एम फाइन विद दैट. बट एक बात और देखिएगा कि दूसरे स्टेट्स में, दूसरी जगहों पर इस रंग की सिचुएशंस को, पर्टिकुलरली हिल स्टेट्स की बात मैं कर रहा हूँ, हिमाचल हो गया, सिक्किम हो गया, नॉर्थ ईस्ट हो गया, वहां पर देखिए वो इस चीज को कैसे हैंडल कर रहे हैं, बिकॉज इट्स worthwhile to learn from others rather than trying to reinvent the wheel every time.
Right.
Well, grateful for both interventions, Mr. Kakru as well as Riaz. Let's go on to the third presentation.
Sir, we have third presentation from Engineer Ajay Sharma, sir, Executive Engineer, who will be presenting on desilting of subtech at some specific scheme as a lift irrigation scheme using slurry pump.
And thank you, Ashok. It was a fantastic presentation. Very, very well done. Let's hear the third presentation.
All right, sir. Thank you, sir. Thank you very much.
Thank you, Riazi. Hello. Am I audible? Hello.
Yes, sir. Yes, sir. Yes, sir, you are.
Respected ACS, sir.
and the dignitaries present. A very good evening to all. During formulation of last year's CAPEX plan and while complying with the directions of working ACSR regarding improved service delivery system through technology adoption, this project was conceived under the guidance of our tech-savvy Chief Engineer, sir. The project was to provide an enduring solution to the repeated silt accumulation issues at various lift irrigation stations on the flood streams as well as the lift irrigation scheme which were constructed on main rivers. Through this project, resolution of two main factors have been approached. One was the regular desilting, especially during the paddy season, and second, to provide a solution to early failures to the machinery due to wear and tear. So this was a very small but an impressive success story which we wanted to share with all of you. Next. This is the structure of Ranjan lift irrigation, which is situated on the river Chenab, and the arrow shows that water from north is going towards the south. The big structure is the sump intake, and the top, the pink color structure is the pump house. A brief history about the river Chenab and why the desilting is occurring, with the water level, the turbidity, and the discharge. There is major variation in all the three cases here in river Chenab because the water level in the lean season starts rising from 8 feet to 35 feet. Similarly, the turbidity, which is around 8 to 18 NTU units, it goes up to 2000 during the peak rainy season. Similarly, the discharge varies from 3000 cusecs to 2.5 lakh cusecs. So there are big changes. So accordingly, that silt accumulation is a regular part of these lift irrigation stations. Next. A brief look on what exactly we do at Ranjan. It has 20 cusecs, 7 pumps, 5 are the 2 are the standby, and at one time we run 5 pumps. So the only problem which we face is that the minimum submergence of every pump is 1.78 meters, and it should be maintained so that the cavitation, water hammering effects, and other things are avoided during the pumping operation. Next. This is just a show of the photograph of the pump house of the Ranjan on the left side, while this is the second on the right is the basic Giant, the column structure where the pumps, 3-stage pumps, VT pumps are already there in the sump tank. These are 7 pumps which are lowered at every particular time, at any particular time, but we are running only 5 pumps and 2 are kept as standby, as I already explained. This is the basic structure of the sump from where from the left side, the water enters from the river Chenab and goes inside the sump tank, and these pumps are situated inside the chamber. The photograph shows the complete desilting. It is during the complete desilting time that the sump is absolutely filled with the silt. These are the photographs where we show that these pumps, which have to lift water up to 61 meters head, they are totally embedded in the silt, and the design ensures that we should have at least 1.73 meters of clear water available at their bell mouths. Now these were the reasons of silt deposition at the LIS Ranjan. There was huge variation in turbidity, as I already explained. The flood always brings silt with it. The silt ejection at all the run-of-the-river hydroelectric projects, especially the Salal, is a regular phenomena, and they often release this silt at any point of time in a day. The gates cannot be closed during minor and average floods due to the demand of farmers, which is at peak because during the paddy season, it is a coincidence that rainy season also coincides with the paddy season. So the coming of the silt cannot be fully avoided in the sump. The silt cannot be removed from the sump is in Ranjan except in the month of January and February when water level is the leanest one. Because the water level below the 8 feet, when it goes in the river channel, then only we can go into the sump tank and remove the silt manually. Another problem which we always face is that since it is only a one-time exercise in a year, so there is solidification of the silt for whole of the year, and we even need power hammers to break the silt before removing it. Now, what exactly is the losses to us in terms of the machinery? The impellers and mouths of bowl assemblies, as I showed in the previous picture, they generally get embedded in the silt. The water column is less, submergence is thus, and the cavitation occurs. There is excess wear of bowl and impeller vanes due to abrasive material in the silt. The specific gravity of the silt water increases and thus more thrust load on the pumps. This often leads to the shear failure of 70 mm dia shafts of stainless steels due to this thrust load, and there is occasional breakdown due to the silt accumulation in the sump tank. This is another picture which shows the total area of the sump tank, and it just concludes from this particular picture that around 1200 square meter of the area is of sump tank, and the silt accumulation varies from 2 meters to 3.30 meters at any point of time at any place. So the overall storage of the overall accumulation of the silt is around 1200 meter cube. This is the picture which shows that before removing manually the silt, we have to engage an earthen bund, or we may call it a ring bund, or we may call it muthu bund, through which we start 2 layers of the cemented bags. This is done by our civil counterparts and a very difficult exercise. And earth filling is done in between the 2 cemented structures. So it itself ranges around 300 cubic meter of material which is brought from outside, then packed in the sump. They are packed in the cemented bags, and then these 2 layers are to be laid on the banks of the river before starting the manual operation of the desilting. It's a big exercise. So this is the figure, and this is the picture which completely shows that how much this the total length of 25 meters of the silt bund, this ring bund, and the other dimensions are already explained in the previous slide. The water has to be closed from entering in the silt tank, in the sump tank, before we start the operation of desilting. These are some of the photographs which were showing that how manually people were engaged, and they were clearing the bowl assemblies of the various pumps to make it fit for the next season. Next. These are another pictures which show that the volume of the silt and the removal exercise, which is a major cause of concern. Now, what exactly is the way forward? How to remove this? This was the planned operation to remove all these problems which we highlighted in the previous slides. So through this particular pump, we wanted to make it as a continuous phenomena of removal of silt clearance by placing this slurry pump inside the sump tank. In order to achieve this, we have finalized arrangement of 15 meter head, 10.8 kilowatt motors with a shutoff of 25 meters, and the average discharge was 3.25 cubic meter. And in case this pump runs around the clock to remove the silt, it may complete the total process by say 15 to 20 days. And this pump can be used at any point of time without waiting for the leaner season, or ensuring that wherever we find a silt or due to any type of the floods, it should be made operational immediately. So the slurry pumps, although were large in number available in the markets, but we face several failures in the earlier due to the various metallurgical requirements which were required for this particular job. So in order to make this process a success story, the thrust was on the metallurgy of the impeller as well as the shafts, so that the excessive wear and tear should be avoided and the life of this pump should be much more. So we, from the various discussions with the various manufacturers whosoever were manufacturing such type of pumps, we zeroed in on high chromium white cast iron impellers. This is a special basic material on the, if we see it in the iron carbon diagram. So the basic thing is that the steels are with only 2% of carbon content, but when we increase the carbon content, we straightway move from 2% to 6.7% in the cast iron materials. And for the white cast iron material, the basic carbon content starts from 4.6 to 4% to 6.7%. And when we add the high chromium in this particular case, it gives more endurability and more abrasion resistant character to this particular impeller. And the wicker hardness, which in normal gray cast iron impellers, which we were earlier using, which was around 300 Brinell hardness, it increases to 600 Brinell hardness. Besides this, this pump was having an internal cooling arrangement. So whether it is dipped fully or it is partially dipped in the slurry, it hardly matters, and the temperature or their failure due to overheating is not possible. Similarly, based on the high chromium white cast iron and the stainer assembly, the stainless steel shafts were with ENX30 and 13% chromium. So all this metallurgy gave us a particular view that after about 50 to 100 hours of working of this, we again checked the basic metallurgy and the finish of the impellers as well as the shaft, but there were no such defect which was observed by us after usage of this pump. Next. This is basically the specification, the photograph of the pump. Basically, this is made in Vietnam, and the Surumi company, which is basic manufacturing, it's a Japanese company who has a base in Vietnam, and this product was imported from this because in India, there were certain manufacturers whosoever were no doubt doing this casting part, but the machining part of such a thing was not possible, as for machining of this very hard material, special tools of boron nitride were to be required, which nobody in the manufacturing area of like Kirloskar and KSV and Mathur and Platt, they were not having such type of arrangements with them. Next. This is a graphic sectional drawing of the pump. Next. This is how we lowered it inside the sump tank, because we had only one crane arrangement with up and down movement as explained, as shown in this picture. But the movement we required was in all the sump area, which we already told that it is around 1,000 square meter of area. So in the first go, we try to do it manually by putting ropes on it, because the weight of this pump was not more than 170 kgs. But in future, after going through the success of this particular operation, we are thinking of placing a crane with having three-dimensional movement on the top of the sump, so that wherever the silt accumulates, we can immediately load the pump at the specific place to remove the silt. Next. This was the first operation when it started removing the water from the major sump to the Chenab River outside, beyond this to the lower side of the sump tank. But the problem here we faced was that the pump was not able to lift the silt, because the silt has already deposited and the internal strainer was not able to break this silt into the slurry. Next. So this arrangement was made by us at the site. So another jet pump was introduced, and from there 2 special jets were thrown on the silt to ensure that the slurry is made, and hence the pump can lift this slurry and throw it downside of the stream. This is the photograph of that jet pump which was placed to break this slurry. Next. Yes. वीडियो तो नहीं है, Is it video? No. Okay. When we pushed this jet pumps on the slurry on this internal silt, the slurry was prepared, and we can see from the other picture that the pump started throwing silt mixed with the water in a very heavy quantity, and it was measured around 2 meter cube per minute. This was the basic financial implication. And while surfing through all the nets and the availability of this pump in various countries, this was finalized at 5.22 lakhs, this pump cost. Although the same pump with natural metallurgy, which we are earlier facing, where the gray cast iron impeller or stainless steel impellers were there, it is around 2.5 lakhs. So price of this component is already 2 times as compared to the earlier which we're using. But the life as projected by the manufacturer and from the various data he has provided is that there will be only variation of 2% of the erosion on the impellers and other wear devices of volute casing after operation of around 600 hours. And we'll see it in the next year when we start operating it, that does this specify good or not. Next. So this is basic benefits which we have achieved. Now effective silt clearance from sump throughout the year can happen. The manpower reduction will be there. Economy of operation by avoiding ring burns will be there. Improvement in operation of VT pumps and life of shafts will improve. Otherwise, these VT pumps have to lift the silt which was there, because if the water requirement is there and the manual operation only start in the month of January or February. So in the other times, there was no other option than the existing VT pumps have to lift this silt along with water. So when this silt will not be there, the total discharge of VT pumps will also increase and the more CCA will be covered. I'll display this video now of this operation of this, which will give quite an insight into what exactly we have said. Thank you, sir.
Yes. Anybody would like to comment? I presume that the mechanical officers are also there. Any one of them would like to? Otherwise, I'll start taking names to find out if people are there or not. Shahid, do you have to say anything? Axial groundwater. Is he connected at all, Riaz?
Yes, sir. He must be connected, sir.
Then he should respond.
Yes, sir. No, sir.
And जी, अपना on करिए video. Why are you hiding?
Sir, I'm not hiding, sir.
Yes.
Sir.
I don't think we required to remind somebody when they come online. They should switch on the video. Yeah, tell me any questions, anything that you would like to ask, Ajay.
No, sir. It is a good effort because
and this is a through manual.
Do you think that there is a application of similar system possible in your jurisdiction in any place?
No, sir. This is the Ranjan is the first where this experiment has been made, and it's a.
No, I know. I'm not asking you that. I'm asking you, do you think that a similar system might be relevant anywhere else? Axion of mechanical department, any of the Axions or SEs would like to respond to this question? That would some kind of a system like this would be relevant in their respective area of work also?
Can I come in, sir?
Who's that? Please identify and speak.
Sir, I'm Iqbal Kirmani, sir.
Yes.
Sir, this can be used, sir, in Dudhganga plant, sir, because we have high turbidity there, sir, in Dudhganga plant. So we have been using, sir. I was there as AW there, sir, for some time. I have been doing this exercise. But as a permanent feature, sir, this can be used in Dudhganga plant.
Fantastic. So I would like Mr. Goli, and Dudhganga किसके restriction में आता है? Waterworks Srinagar?
Yes, sir. Yes, sir.
तो Waterworks Srinagar इसको करके देखें. अगर आपको विजिट करने की जरूरत है, यहाँ पर अजय के पास में जो सारा सिस्टम उन्होंने किया है उसको भी देखें. Good.
Sir.
Who else would like to respond to this? Any of the other mechanical officers would like to? SE Mechanical, Mr. Bodraj would like to speak from here. I hope your voice is caught here. Yes, बोलिए.
सर अगर ये इसका ये स्लोप है जो जैसे हमारे पास 7 मीटर है सर बोलने में हमारे 7 मीटर का होगा. अगर हम इसको 3 मीटर का एक एंड बना के इसको स्लोप ज्यादा करते हैं और उसमें जो हमारा सरी जो भी हो सारी आपके इसमें इकट्ठी हो जाएगी. यहाँ पे हम परमानेंट पंप लगा सकते हैं.
So इनका पॉइंट ये है that अजय इनका पॉइंट ये कि जो
परमानेंट हमारा रहेगा इसको फिर
एक मिनट. इनका पॉइंट बेसिकली अजय ये है that you create a natural flow of the heavier load to a particular area so that your pump does not need to be mobile and move around. It can keep on pumping out from the same point. Is that what you're saying, Bodraj? Do you think this is something which you would like to try?
Sir, we will try this in this particular year because now we don't have to wait for silt deposition. Now we will start doing this after every 10 days, every 15 days. So wherever.
That's fine.
Yes.
That's good. That's good. Perfectly true. But then this is a design input to the to our DIQC which is going to come in. That we need to be cognizant of the fact that we are going to always get affected by siltation. Always. We are in a place जहाँ पर silt होना ही होना है. तो बोधराज जी आपका जो suggestion है उसको थोड़ा सा study करिए. This place is nearby. Please have a look at it.
उधमपुर में लगा सकते हैं. हाँ हमारे जो सलमे है सलमे में सर वहाँ पे बड़ी प्रॉब्लम आती है.
तो उधमपुर सलमे में भी आप ट्राई करिए इसको.
ओके सर इसको बना देते हैं.
राइट. उधमपुर सलमे में ट्राई करेंगे. अशोक ये आपको देखना होगा. So we have 2 places we have identified. किसमें? All right. So 2-3 places. Now I'm noting it down. DP साहब नोट करिएगा. ये immediately हम MNR के थ्रू ही इसको करके immediately करेंगे या कैपेक्स में डालें तो वहाँ पे भी डाल सकते हैं. उधमपुर तवी में जहाँ लिफ्ट करते हैं वहां पर और ये इधर दूधगंगा बोला है और भी कोई जगह आप सेलेक्ट करें. 4-5 जगहों पर हमें करना चाहिए. नाउ यस वसंतपुर वगैरह वो भी है. कोई बात. तो therefore see Ajay, grateful to you to put it in a very structured manner. आपने काफी अच्छे तरीके से एक्सप्लेन किया है सारी बात को और फोटोग्राफ्स भी हैं उसमें, वीडियोस भी थे. इसको भी थोड़ा और अच्छा करिए. एक सेंस में आपने बेनिफिट/सजेशंस दिया है. ऑल ऑफ अस इंजीनियर्स नीड टू रियलाइज समथिंग. हम एक कोर्स पढ़ते हैं जिसमें हम कॉस्ट बेनिफिट एनालिसिस देखते हैं. आई थिंक वी ऑल नीड टू अंडरस्टैंड दैट जब किसी को आप कन्विंस करना चाहते हैं तो यू हैव टू सी इट फ्रॉम द अदर पर्सन्स पर्सपेक्टिव आल्सो. यू कैनॉट हैव योर पर्सपेक्टिव एंड एक्सपेक्ट दैट द अदर पर्सन विल अंडरस्टैंड. सो व्हाट आई एम ट्राइंग टू से इज that if I was to put this kind of a system and it is going to cost me 10 lakh rupees, while I understand that 10 lakh rupees for such a important scheme is not a problem, but suppose मैं इसको फाइनेंशियल साइड में देखूं, बोला क्यों भाई 10 लाख क्यों खर्च करने, मैन्युअली निकाल तो रहे हो और वो ओवर ए नंबर ऑफ ईयर्स आ रहा है, why should we do? So for people who will raise these kind of observations, you need to understand from their perspective. Therefore आपकी एक स्लाइड थी इसमें बेनिफिट/सजेशंस, उसमें 6 पॉइंट्स थे. उन 6 पॉइंट्स को इकोनॉमिक उसका बेनिफिट इंडिकेट करें जी. इट्स अ वेरी गुड स्लाइड, द इकोनॉमिक बेनिफिट साइड. बट इन दैट बेनिफिट्स नीड टू बी monetized, so to say. It needs to be represented in money form. what does it mean? And इससे भी बड़ी बात यहाँ मिस्टर मनचंदा ने बोली, उन्होंने बोला कि साहब ये सब तो ठीक है, इफेक्टिव सिल्क क्लियरेंस भी हो रहा है, रिडक्शन इन मैनपावर भी है, इकोनॉमी ऑफ ऑपरेशन भी होगा, improvement in operation of VT pump and life of shafts. This is what he was probably saying. That's not ये जो aspect है, operation of VT pumps and life of shafts. In fact, the biggest improvement is in that.
Yes, sir.
And Mr. Iftikhar Kakru is here, and he was. I was in PDC when both of us worked together for some time, and I still remember in Lower Jhelum plant or some other places, the manner in which silt completely erodes the turbine blades. It is unimaginable. And therefore, I can fully well understand that the increase in the shaft's life in the pumps, VT pumps, uske fins वगैरह में is going to be substantial. This is the cost which will probably justify everything. This one single cost.
Yes,
Added to that, the fact that there can be more CCA, which Mr. Manoj, the Chief Engineer Irrigation, was explaining here. All these things need to be captured. So please give some more time to this presentation. Come out more clearly about this thing. And grateful to you, Ajay. So
Thank you.
what I guess is that each one of you is trying to do some exceptional work. Ajay could have simply avoided it, continued with his usual practice. कोई issue नहीं था, कोई मना भी नहीं करता, कोई देखता भी नहीं शायद. लेकिन the fact that you made an attempt to find a permanent solution, the fact that there were other officers around you, maybe Mr. Manoj, the Chief Engineer Irrigation, and the fact that you could try this, there were resources made available to you. You all need to realize that those resources in some other times might not have been available, but they are available to you today. So my point is, this is the time to innovate. This is the time to exercise your mind and think of solutions, out of the box solutions, which uses your engineering knowledge. मैं आप सभी को invite करता हूँ इस बात के लिए कि कोशिश करें. अब जैसे मिस्टर किरमानी ने immediately point out किया that दूध गंगा में possible. So these are the things that we need to learn from others and put in here. मैं एक बात आप सब लोगों से request करूंगा that each one of you is doing some or the other wonderful work in your respective area. So do not be afraid or do not be hesitant that मैंने जो काम किया वो इतना बड़ा नहीं. मैं अभी मनचंदा जी से और मनोज जी से पूछ रहा था कि भाई कितने लोगों ने volunteer किया. I understand very few have. But my request to you would be, don't be hesitant about this. Whatever you have done, even if it is a 5 minutes thing, it will be worthwhile to see it. Because what you will do, that is a proof of concept. At least what Ajay has done is a POC. That proof of concept is now available to all other engineers to see. And if anybody is doing something which is a POC, I think it's our moral duty also to bring it to the notice of all our colleagues that we can improve the function of the Jal Shakti department. Well, that's what I have to say. Mr. Kohli wants to make an intervention here. Yeah, please go ahead.
Is this a solution for the high traffic during the for the filtration?
Yes, but उस समय आपके हाँ सोचिए.
This can be a solution.
मतलब मैं वही कह रहा हूँ.
Bypass करना है, then this is the solution.
We need to think about it, and the DIQC that I have in mind, Kohli साहब आप सही कह रहे हैं, try करके देखिए. तो और I hope JJM की तरफ से उनके जो retired officers हैं, जिनको हमने रिक्वेस्ट किया है, उन्होंने कंसल्टेंट्स की तरह हमें ज्वाइन किया. दे आर आल्सो कनेक्टेड, वाहिद एंड ऑल मेनी अदर ऑफिसर्स हु आर देयर, हनीफ एटसेट्रा. सो Riyaz, are they connected with this?
Yes sir, they are connected, sir.
The objective is basically to get the best talent that we have, who have worked with us, who know the limitations of the government system, and at the same time also know the scope which the government systems provide. So this workshop series need to be taken forward by all of you. I would request each one of you to think about it. For example, I can see XCN QCPD right there on the screen. And if you have worked out systems by which you try to ensure that the quality of pipe coming is good, or nothing else, simply what is the quality control check that you're doing? Make a presentation on that. The advantage would be others will see it, they'll comment on it, they'll say ये ठीक हो रहा है, ठीक नहीं हो रहा है. तो मेरा आप लोगों से सभी से रिक्वेस्ट रहेगा कि rather than being hesitant about things, come forward, share your experiences with everybody. This is so far a knowledge sharing. अभी तक ये knowledge sharing, अब मैं I'm coming to the next point because we should end this meeting. But so far we have been doing knowledge sharing. Now I would like to identify some topics which will be touching the second aspect of this workshop series, that is ideation. Ideation is ideas which we need to throw around and have a discussion. तो रियाज आप अपने वेबएक्स के सिस्टम को कंट्रोल करने के तरीके को देख लीजिए. You should know how to do that. I would like officers of senior level or otherwise to think of certain ideas on which you are stuck. You're not able to find a solution, or a problem, not idea, a problem. And what could be the possible ways by which we resolve it? Something which is a challenge. I think time has come. We are now a few series or a few workshops old in this entire process. I think we need to come up with that and discuss ideas to resolve specific problems. So this is what I have to say. And anybody else wants to make any intervention? Yeah,
Can I come in, sir? Can I come in?
एक सेकेंड, just a minute, Mr. Bodra has to say something.
बहुत सारे फिल्ट्रेशन प्लांट बनते हैं हमारे और इसकी
Interconnection.
हमें जो प्रॉब्लम होती है इसकी सफाई जब सेट हो जाता है, इसकी एक आइडिया मतलब ये है कि अगर इसको हम ऐसा करें सिस्टम भी उसको 6 महीने के बाद जाके ऐसे पीरियड को फिक्स हो जाए.
तो जो बात मिस्टर इफ्तिकार कपूर अभी कह रहे थे कि we need to think of SOP on filtration plants is true. In fact, the number of civic structures which are now coming up, and Riaz was giving me that data, it's huge. What we have not done in the past 60 years is taking place in 1 or 2 years. So we have to massively organize ourselves that our focus changes. So Riaz, I would request you, in consultation with your colleague officers, you need to think of a number of ideas. Let everybody, I am saying, let them just post the idea to the email. Let them post the challenges you think are going to come. Let it come on Manoj's group. ठीक है. एक और चीज है जिसपे मैं अभी मेंशन करना चाहूंगा. I am asking people to work on the vision document 2047. Now you recently saw the floods that took place in Dubai, and I happened to Google and I discovered that a colleague of a friend of mine, a student when I was, he was doing PhD in atmospheric science. So I Googled and I discovered he actually was one of the persons in Tailed Arabia. It was written that Mr. Mukul Tiwari, a professor in Colorado University, had visited in 2020. So I called him up and said that you caused floods in Dubai. But the fact remains that on atmospheric sciences, they've been working for the past 20 years. And it is this cloud seeding and the manner in which the rains take place. This entire world is moving in a direction like that. So I think the time has come that we do not remain stuck on these ideas only, which are traditional ideas. And I'm talking about everybody. And those people who are elders in this family also, the family of hydraulic engineers, need to understand this, that the relevance of their experience and their ability to guide the people is going to remain. Because this country is increasingly realizing that retirement should not be the basis on which we consider the importance of a person, his significance in contributing to public life. There are ways and means by which these people get associated with regular projects. So मेरी request रहेगी कि आप जब भी आइडिएशन वाली बात करें, दूसरी बात करें, उनमें ये भी सोचिए कि कौन से नए तरीकों पे हमें ध्यान देना है. That's all I have to say. And Riaz, unless somebody wanted to speak from there. I
want to say something, sir.
Yes.
Sir, with regard to the specific presentation about the use of pumps, slurry pumps, just 2-3 points. One is that I think the department needs to do an audit of the gates, the gates and the trash gates for both irrigation as well as the PHE schemes. Because in most of the cases the gates are not working, and which is one of the main reasons for the silt to accumulate in these sumps and these wells. Number 2 is that the operation of these slurry pumps has to be done in a coordinated manner along with the projects in downstream of this particular project. Because once you discharge the silt back into the river, the pump stations downstream of this particular project, they are at the risk of receiving the silt and the consequent damage to their pumping equipment. So we probably would need to devise a plan for the river stretch as a whole, and devise a plan for installation of these slurry pumps in all the pumping stations, and doing these silt clearance in a coordinated manner. And number 3 is which is very important for you. Probably this is food for thought for you, your good self, sir, because you are now at a stage where you can frame policies and take the department to a different level altogether. I think this also calls for the concept of slurry pumps for silt clearance. it also calls for review of the distribution of work between the mechanical and the civil divisions. But currently, I think in PHE, there's this sump to dump thing, which was coined in the past, that the mechanical divisions have the responsibility of water from the river to the filtration plants, and likewise onwards from filtration plants to it is the civil division. But once slurry pumps are put into operation, the whole thing changes. Then in that case, the responsibility of clearance of silt from these sump tanks and these sump wells would have to come to mechanical department, because they would know when to put the pumps in operation, the slurry pumps and the jet pumps. And also the fact that this manually, when you remove the silt, you assume that the silt is taken to land, but in this case the silt is coming back to the river. And then there is an environmental angle also. We might have to think of mitigating the damage on account of
environmentally, I am only decreasing the entropy. I am taking the silt back to the river, so you don't need to worry on that. I hope. Going back to it. No, but Kapru Sahab, absolutely valid points. I could see some others in agreement here where I am sitting. And I think, yes, we need to actually look at this carefully. But one thing that Director Planning and Hitesh, अगर आप connected हैं, Additional Secretary वगैरह, Hitesh आप हैं इसमें? Hitesh हैं? We need to urgently conclude our consultations with regard to cadre review of the Jal Shakti Department. Our entire process needs to reach a conclusion, and we need to have a place where ideas, the knowledge sharing, the out-of-box solutions, all this is possible to be on a sustained basis. A DIQC, which is not merely an inspection unit, and some place where a chief engineer would say, "Yaar, hame dump kar diya hai." This, the very fact that the usage of such words is done, is an indication of the importance that we do not accord to certain units or organizations. So I think we need to make them extremely vibrant places. Yes, Manu. This is how I know you were saying that, but these are places which have to become so vibrant that they virtually become the drivers for all the innovation which is brought in. And therefore, Hitesh, I would say I'll name the DIQC differently. I would call innovation as a part and parcel of its very structure. It can be design, innovation, and quality. It could be something that brings the new focus, the new manner in which we look at it, new paradigm in the focus. Thanks, Kapru Sahab. And right then, now being 6:30, old people probably are okay with working very late, but the younger group would not be. So we'll end this discussion now. And we'll see if the Saturday has to be changed. I'll do an internal consultation. Thank you very much. Thank you, everybody. And Ajay and Amreen and Ashok, thanks to all three of you also, and everybody who has joined. Thank you very much.
Thank you, sir. So I'll see you on Monday, sir. I'm coming to Jammu on Monday.
Yeah, sure. Most welcome. Right.
Thank you, sir.
Okay. Thank you.